Hey, what's up guys, and how is it going? So in the previous tutorial I taught you how to run object detection right in your IDE using Yolov8, and it was very simple, and I can see in the comment section you guys love it. So in this tutorial we are going to leverage on that basis and do object segmentation right in your Python IDE. We are not going to use Google Colab for this, so you can use any IDE of your choice to perform these tasks. So before we get started, if you have not subscribed yet, do me a favor by subscribing, putting me on post notification so that you don't miss any of my future tutorial. So as usual, I have some files here that we'll be using. I have a lot of video files we'll be testing in this particular tutorial. So about 3 video files, and then we have the classes.txt. So these are the objects we can detect by default using the Yolov8 module. It's about 80 objects by default, and we'll be working in the main.py directory, and this is another video, motorbikes.mp4. Then finally we have the Yolov8 segmentation model. So don't worry if you don't have this model. When you run the code for the first time, it will go ahead and download it for you. So all you have to do is to make sure your laptop is connected to internet, or if it's a desktop, make sure it has internet connectivity. So let's now begin by importing our dependencies. We import opcv, so we import cv2 and we import it as cv. We also import the math module, so we import math. We import YOLO from ultralities, so we say from ultralities we are importing YOLO, and guess what, YOLO should be in cap. Then finally we import CV zone, and we use this to design a nice rectangle and also put text on our detected object. So we import CV zone, and that's all. So this all for the imports. The next thing is to load in our video file. So since we have so many video files here, we'll just load the first one, which is bikes.mp4, and then when we are done with the segmentation, we'll test other video files using the same code. So we just say cap is equal to cv2.video capture. So in this case cv.video capture. Then inside this function, as usual, you provide a path to your video. So our video name is bikes.mp4, and that is it. So by this we are creating a capture which is leading us to our video file. Then now we have to take this in a loop, so I'll quickly write this. If you have followed the previous video, I explain each line how to read in this video and play it using computer vision. So we'll create a while loop, while true. Okay, so we create a while true here, or while loop here, because we'll be taking this video in a loop. Since it's a video and it's not an image, we'll take it frame after frame. And this function cap.read returns us with 2 variables, one being our video, which is what we are interested in, and the other one being the absence or presence of a video feed. So if there is no video feed, it's a boolean value, it will be 0. In case there is a video feed, it will be 1. After this, let's just display our video. So cv.imshow, provide your window name, you can put whatever there and what you want to show, which is the video. After showing, you have to wait as always, so cv.wait key, and in here you put wait key of 1. You want to take each frame, each second, or 1 second you take each frame, and that's all you need to read in your video file. So let's run it to see the moment of truth. So this is the video file we'll be working with. It's a very short video file, so I think let's also go ahead and resize it, because some of the videos are not having the same size. So let's resize it. Okay, so in here we are still storing it in a video variable, and we use cv.resizing, which will provide the video we want to resize. Then we give it the size we want it to be, and that's it. So if I run it now, you'll get a new size video. You can see this is very small and it's very good to work with. You can give it any size you want. So this is the width and this is the height. So that's it. So now after reading and loading and resizing our video, this is the part where we have to send this video feed into our YOLO model to process. So we have to first create the model here, which will say our model is equal to, then just write YOLO all in cap, and you provide the type of model you want to use. So Yolov8 has a numerous model or several models, but in this case we want to use the segmentation model. So you just have to write Yolov8 then S, because you want to do segmentation, and hyphen seg.pt. So this is the particular model we are using for the segmentation, and all you have to do here is to send in your video feed into this model you have created. So we'll store that in results, and this is equal to our model. Then in here we give it our video. We specify that stream here is equal to 1 or is equal to 2, and that's it. So now we've sent in our video feed to YOLO. So YOLO will process this video feed to see and detect objects. But in every object detection and object segmentation task, we will need certain information such as the bounding box, the detection confidence. We also need the class names, which class of object is it detecting. Is it a human being? Is it a dog? Is it a bird? And so on. So all those classes are what are in the classes.txt file. So we have to loop over the result files for some number of times in order to get our actual information. So we'll say for any info in results, we can put this in another variable that our final result, let me put it this way, final result is equal to info.boxes, and that's it. So now whatever we are getting from this result, the authorities documentation shows that you have to just take it from this info and do info.boxes in order to get all other stuffs that you need. So the other stuff will be the coordinates. So first we take the coordinates, which is x1, y1, x2, and y2, and this is equal to our final result dot xy at index 0. So with this we'll be able to get our bounding box, and we will not stop here because we also need the confidence. So we'll do it for the confidence, which I'll write confidence, and this confidence is also equal to our final result dot conf, and in here we will also take it at the first index. And for the last time, we are going to take for our class detected, so we can call it class detect, and this class detect is also equal to our final result dot class. So CLS for class, and we are taking at the first index. Okay, so now that we have gotten all these parameters, we have to go ahead and draw a bounding box on any detected object in the video field so that we know YOLO is accurately detecting objects in our footage. So for that, we'll use CV zone to draw a nice rectangle on every detected object. But the thing is, these variables here, x1, x2, and everything we are getting from final result.sy is a floating point value. They are float values, so we have to convert them or cast them back into integer values before we can use them. So for that, we'll do x1. So just copy this and repeat it. Bring it down here, and this is equal to integer value of x1. So we have to do for all the remaining ones. So I will do it for all the remaining ones. Okay, so the arrangement should be the same. X1 should be S1 here. So we just do the same thing and arrange them just as they are here and convert them to integer. So having them as integer value, now we can just draw a bounding box with them. Later on, we also convert the class detect to an integer value. So I think we can also go ahead and do that at the top here. So our class detect is equal to the integer value of whatever class detect was, because they are all floating point values, and we convert them to integer. I'll do the same thing for the confidence too. So I'll say conf is equal to, so for the confidence, we use the math value to seal it. So when we seal it, it will be a percentage value instead of being any floating point value or any decimal value, 0.5, 0.6%. So we'll make it, if it's 20%, sure that whatever it has detected, whatever object is detecting is a human being. We want to see 20% there. So we use math.seal function here, and in here we put our confidence and multiply it by 100 in order to get it in percentage. So now that we've converted all of them, we are coming to draw the rectangle using CV zone. So use CV zone.corner rect, and in here we want to put the rectangle and our video and our video footage. Then we specify that I want to put it on x1, y1, and we also want to put it on the height and the width, but we don't know what the height and width is for now. So to get the height and the width, we'll come up here, and the width, we say width height is equal to, so to get the width we subtract s1 from x2, so x2 minus x1, then we also subtract y1 from y2, so y2 from y1, and this will give us the width and the height. So that's it. With this we can draw our bounding rates. We can specify other things, but I think by default it works great. So at the moment of truth, let's test this out to see whether or not we'll get any detected objects. And boom, so you can see this is segmenting the objects, the bicycle riders, the bicycles too. So our segmentation is working. You can see someone left his steering. These are great bike riders, and everything is working just as a charm. So now we'll continue to get the particular class being detected. So if it's a person, we want to get person written on it. So for that, you have to come and read this file into our project, and then we'll just equate it to every number being detected. So I'll come at the top here, and what I'll do is that I'll say class names is equal to an empty list. Then we can now read in our txt file here, classes.txt, and we are reading it, so we put r here, and we are reading this as f. So our class names is equal to f.read, and we want each of them to be in a separate line, so dot split lines will be our best method to use. Okay, so after this we can come here now, that's the class detect. So we can come under the class detect, and we can say, okay, our class name, so here we'll make it our class name detect. Let me do this way. Our class name detect is equal to our class names in the key of whatever class detect is. So whatever we are getting, so that means if this one will give us an integer value from 0 to the last number, our last object here, which is 80. So we are saying if we are getting number 1, let's equate it to person. If we are getting number 2, so since we are using Python, we know most of all the program languages indexing starts from 0. So person here will be number 0. So whatever we are getting, we are just equating it to the actual name here. So that's what we are doing with this line. And now we also have the confidence here, so we can detect based on confidence. So what I'll do is that I'll come here and come down, and I'll say, okay, if our conf, which is conf, is it conf? So let's do this config. That is a very weird variable name, so I'll do it confi, that's it, is greater than 60, which is 60%. We'll go ahead and do whatever that is here. We'll go ahead and detect these things and put the bounding box on them. And then finally we are going to put the test. So we'll also use CVZone to get a nice test. So CVZone.put text rectangle, and in here we want to put it on our video. The second thing is the text we want to put, so that will be our class name detect. And finally we want to also show the position we want to put this test. So the first position, let's put this in the list, we'll do x plus 8. So this I've checked beforehand. And then next one we'll do it y minus 12. So we don't have x and y, we only have y1 and x1, so we quickly change them to that, and that's it. So we can specify the scale to, so I'll specify the scale to be 2, and that's it. So let's now run and see. Okay, so it has detected that this is a person, so you can see person written on them. It's not detecting them quite well because you have done a mistake here. Though it will work with this, but you will have a false detection. So what we'll do is that before we take this result, final result is equal to info.boxes, we have to loop over this final result again before we take our coordinates. So what we'll do is that we'll say for my results in final result, then we can indent everything here, and then instead of final result being here, we'll take everything from my result. So this is a mistake I've done, so let's correct it and see how well it will now segment whatever object is seen. I think that's also now. I'll run it, and I'm going to run it on the first bikes.mp4. so let me quickly run this and let's see. And voila, so you can see it detects well now than the other time where we are having very few detections, because I forgot to loop over it one more time. So you can see even the traffic light is being detected. So this works great, guys. Let me know what you think. With only few lines of code, we are just segmenting anything you are seeing using Yolov8. Big shout out to Ultralities once again. So we can continue with the motorbike video. So motorbikes.mp4, let's check it out too. You can see it's also doing great. So guys, this works, and what I like most is about the number of lines of code you have to write to get this working, which is pretty much straightforward for everyone to test it out. Let me know what you guys think about this in the comment section. Also, don't forget to share to make this community grow. You can leave video requests or any suggestions for this channel in the description as well. Finally, before we bring the tutorial to an end, let's test this on the cars.mp4. And boom, so you can see how well it's detecting them and segmenting them at the same time. So this works great, guys. I love it. This is very easy. So let me know what you'll be using this for, what projects you are looking forward to see with this kind of detection. I think it's accurately detecting all of them. So if you like this video, kindly give me a thumbs up, subscribe to the channel, share this video with one or two people who might need it, and also make sure you put me on post notification. As usual, I'll see you in the next tutorial.